In our previous video, we discussed the basics of reflection. We have seen reflection objects are used for obtaining type information at runtime, and the classes that give access to the metadata of a running program are all available in the reflection namespace. So based on this discussion, we have seen a demo program, and we have also seen how the reflection object can be used in our program, how the reflection objects can be used in our program to access these metadata. So in continuation to the demo program, we can see the system.reflection namespace contains the classes. We have seen the constructor info, member info, parameter info, all these classes are available in the reflection namespace. This will allow you to obtain the information about the application and to dynamically add types, values and objects to the application. So you may be wondering, like, why should I have to access the reflection information? Why should I access all this reflection information in my program? Because I am the creator of the program, then why should I know the information about the constructor, methods, parameters, etc. Now this reflection objects are mainly used when you are using any other library component which was created by someone else. Say for example, you have added a component or a class which is available in someone else's namespace, but you are using it in your program. So during the program, you just want to know what are the parameters available in a particular method, or what is the data type of each and every parameter. Accordingly, you want to invoke that particular method. If this is the case, then I have to use the reflection namespace, because you may not have an idea about how many methods are available in a particular class, or how many parameters are there for a method, or what are the different types of parameters available in a particular method. So if I want to know these information of a class which is not created by you, it is not created by the programmer, it is created by some other programmer, but you are using it in your application. In those cases, you may want to know the metadata, which will be easily obtained or done using the reflection namespace. So that is the idea behind introducing the reflection objects. So your reflection provides objects which can encapsulate the assemblies, modules and data types also. So you can obtain the information about the assembly itself, or about the different modules in a component, or even in an application, or even the different objects, information about the data types. And the reflection is the process by which a program can inspect or understand or make use of the metadata information dynamically, and which will be done by the reflection application programming interface. Now using the reflection, these are the applications, I can say, or I can put it this way, these are the advantages of using the reflection. You can create instances of your data type. So you can access the data type information, then you can go for creating an instance of that particular data type. And you can bind the data type to an existing object, that can also be done. Or even you can get the type from an existing object, or you can invoke the methods, or you can access the fields and properties of a particular class. You can view the metadata, or you can reflect on a data type, or you can even do the type discovery. So these are some of the things that I can do with the reflection object. Now the reflection object is somewhat similar to the runtime type information which is available in C++. In C++, you have a facility called as runtime type info, RTTI, which will help you in accessing the information about a data type during the runtime. So while executing the program, I just want to know how many parameters are there. I just want to know what is the data type of a particular parameter, or I just want to know say what is the return type of a particular method. Then you can make use of this runtime type info, which is available in C++. The same way here in C# programming, we can use the reflection objects to access this particular information. Now the biggest difference here is the reflection in C# will work with the managed code. When I say managed code, yesterday we have seen in the .NET framework, the managed codes are nothing but the assemblies that are created by the .NET compatible compilers. If you have .NET compatible compilers, these compilers will be generating an intermediate language code, which you call as Microsoft Intermediate Language Code, that is also known as the assembly of a particular program. And the reflection is, comparing to C++ RTTI, the reflection is much powerful, where you can access all the metadata information. Now the system.reflection namespace defines the following data types or the classes. You have class for assembly, you have module, enum, the method info which we have seen in our demo program, constructor info, member info, parameter info, type. So these are the 5 classes we have used inside our demo program. So please recollect the points there. Apart from that, I can have field info for each data member. Field info gives you the metadata about the data member. Event info, if you have declared any event inside your class, then the event info can be obtained using event info. Property info, right? Assembly is one of the class which will give you the metadata that is available inside the assembly. Suppose, say for example, in your application you are using a component which is a component or a library module which is in the form of .dll. Then obviously .dll is an assembly, and you want to understand what is the version of that particular assembly, or you want to know who is the creator of that particular assembly, or you want to know what is the security information provided in that particular assembly. So these kind of metadata can be accessed using the class called as assembly. So these are different classes that are available inside the system.reflection namespace. So this is an example member info object of the system.reflection class. This has to be initialized for discovering the metadata associated with a particular class. So what are the different members available in a class you want to know? You can make use of member info. Member info is a class which is available inside the reflection namespace, and if you want to understand what are the members of a particular class, I can make use of this object, but this object is to be initialized. So that is why in our program we have initialized the parameter info with a null value. So like that, in the same way, member info should also be initialized. So if I want to initialize, this is how you will be initializing. You can have member info, specify an object and use type of, then type of operator, then whatever class you want to use here. So suppose if you want to understand or if you want to collect the members of the employee class, then what you can do? Member info, then the object name is equal to type of operator. Inside the type of operator, pass employee. Employee is a class name, right? So employee will be passed here instead of my class. This is a user defined class that you have in your program. Observe the example here. I am defining a class A, and I am having only a method, a display method, right? So I just want to access the information about this particular class. So how do you do that? Declare the class, another class, declare a main method or any other method. You are going to define an object here. object S is of class A type. Where is class A? I have defined class A, which is having one display method, right? So I am defining an object here X, which is of class A type. Then I am just invoking the display method, right? So just to understand this object is working fine. Then I am using the type of, and this type of is, and you can observe here, I am going to use the member info and it has to be initialized with a particular type, right? So that is what we are doing here. I am going to use the type of operator and I pass the class name, and whatever is the type of this particular class will be stored in the variable or an object called T. And T is again a reflection object. How come it is a reflection object? See here, the type is a class available in the reflection namespace, which is a reflection object. So I am defining an object of type TYPE, which is a reflection object. So obviously T becomes a reflection object. Now this object will be accessing the method information, or it may be accessing the property information, or it may be accessing the parameter information, etc. So what I am going to do, I am going to access the methods of this particular class. So how do you access it? Use the object name, then use the get methods method, which will be returning all the methods of which class? Class A, right? So this, when I say get method, each class may be having more than one method. So I cannot store it in a single object. I need an array of objects to store all the method information. So that is why you can observe method info is declared as an array. What happens? Mi is now an array of objects of what data type? Method info. Method info is a reflection object. So mi becomes an array of reflection objects. For what we are going to use this mi? Mi is used for storing the information about the methods. How do you get the methods? I can invoke the get methods method of the data type T. So all the methods available in this particular class will be accessed and it will be stored in an array of object called mi. Then what I do? As usual, I use the for each method, for each loop, and inside the for each loop I am going to access the methods one by one. I access the methods one by one, and you can see here the property name of this method. M is one method in the array of method objects. M is one method in the array of method objects. Mi is an array of method objects. M is each method available in that particular array of objects. So for each method, I am accessing the name of the method. I am accessing the return type of that particular method. I am accessing the name of the method. I am accessing the return type of this particular method. So this is how we will be viewing the metadata of a particular class. So this is another example of which is given in your Balagurusamy textbook. You can use the reflection namespace, and I am defining a class here. Inside the main method, I am using assembly.load. Observe here, assembly is another class available in the reflection namespace. So what you do here, assembly object is declared and you are using the load method, which will be loading 1DLL. I told you assemblies can be used for accessing the metadata of a library component, which will be in the DLL format, or it can also make use of the .exe. So here I am just passing one library component which is in the DLL format. I am going to load that assembly in this particular object. Then I am going to get the types. What are the different types available inside this assembly can be accessed using get types, and I am going to store it in the type array, and I am just displaying the values of these data types, right? So this is another example of reflection. This is a third example. You can see here I am using the reflection namespace, and I am loading the library. I am loading the library component into an assembly object, and I am using the get type. Here I am getting all the types of the assembly which I am storing in the array of object. But observe here, I am getting only one type. I am getting only one type, and I am storing it in a single object. So I just use get type. Here it is get types. I am not passing any argument, but here it is get type, which will pass one class name. System.console, please recollect, in all our console based application program we have used console.writeLine, console.readLine. So console is a class that is available in system namespace. So I just get the type of this particular class, and I am storing it here, and I just display what is the type I have accessed using get type. So this is another simple example for how we can make use of reflection object to access the metadata, right? So these are the different applications of reflection. Reflection has the following application. It helps you to view the attribute information at runtime, and it allows examining various data types in an assembly and instantiate these types also. That can also be done. See, it is not only used for accessing the type. Whatever type you are going to access, suppose you are going to access this particular type and you want to create an instance of this type, that is also possible. That is the advantage of using the reflection. See, this is what happens when someone else has created a class in a namespace and you want to make use of it. So what you do, you want to get all the types that are available in the namespace, and if you want to create an object of that particular type, that is also possible. And it allows late binding, obviously, because you are going to access the methods, parameter, all the information only during the runtime. So obviously it allows late binding to methods and properties, and it allows creating new data types at runtime, because you can access the information of methods or classes during the runtime. By the time when you come across a type which can be used in your application, you can create that particular object. That is the purpose of using the reflection at runtime, and then perform some task using those data types. So these are different applications you can say for the reflection object. So in general, what you have to understand here, the reflection is a namespace that contains different classes. Using these classes, you can obtain the metadata information dynamically. Not only that, you can add new data types, values and objects to your application just by accessing them dynamically. So let us see this example program before we wind up. Let us see how this program is getting executed. So we are going to see this program. Let us see what happens in the program. Using system dot reflection. So you are declaring class A and you are declaring class B with main. Okay, let us try compiling this program. Public, it is not capital, it is small p. Type of system.console does not contain a definition for write line. Yes, it is capital L. Static main method, did I not declare it as static? No, it is not declared as static. Yes, we are done. Let me run this program. You can see here it shows one method information which is display, and I have already told you in the previous video we have seen these are the other methods that are available by default in any user defined classes. ToString, getType, getHashCode, equals. These are the methods by default the C# will be adding to all the classes. Whereas here in our program the class A is having only one method, display method, and if you want, let us add one more method here. I'm adding one more method. So let me compile the program. Let me execute the program. You can see here it shows display and hello. These are the two methods we have defined, user defined methods, and these are the predefined methods that are available in any class that you are going to define in your program. So this is how we will make use of the reflections in our program to understand the metadata dynamically. While executing the program, you want to understand the information about the classes or the objects or the methods or the assembly or the parameters and whatnot. If you want to know that information, you can make use of the objects or classes that are available inside the reflection namespace. Thank you.